This lesson is going to be about compound inequalities. Now that we've already done multi-step inequalities, compound inequalities is just another step to that. But first we need to know the definition of a compound inequality. And what that is, it is two inequalities or more joined together with and or statements. And we're going to talk about both of those. The first one we're going to talk about is that or statement. When you think about the word or, like if you had fish or chips, there are two different pieces to that. You either had one or the other. So or implies that you have more than one. So or inequalities have a tendency to graph apart from each other, because there are two separate pieces. For example, you can have x is less than or equal to -2, or you can have x is greater than 3. So how would we graph that? We're just going to graph them like we did with inequalities. We're going to graph this piece first. Remember how it's written, least to greatest. Variables are always on the left, but because my target number, -2, is less than 3, that's why it's located on the left-hand side. So we always go least to greatest, and you'll notice on an or statement that my arrows, when we graph, they are going to go apart from each other, okay? So let's graph this first part. X is less than or equal to -2. So I bubble in -2, and x is less than, so x is all those values that are less than -2. So that's what that graph looks like. And then we have x is greater than 3. So it's open circle on 3, and we shade all the numbers that are greater than 3. So look at all these different solutions. The only ones they can't be are located in between there. Okay, now that's how we graph it. Now we have to give it interval notation. So we do it the same way we did on multi-step inequalities. I'm going to put this in interval notation, and we always start my graph left to right. So it goes infinite to the negative. So negative infinity, always with a parentheses, comma. It stops at -2, so I bracket it. Here's what you need to remember. You must include the word or between those because it's two separate ones. We have negative infinity to -2 bracket or parentheses 3 to infinity. Notice it's open circle, so it's a parenthesis. And of course, infinity, whether negative or positive, always has a parenthesis around it. So these are the same things that we've been doing with multi-step inequalities. We just have two different solutions. So we're going to graph the same way. We're going to solve the same way. So I'm going to add 4 on both sides, and I get x is less than -3. I divide both sides by 2, and I have x is greater than or equal to 6. Notice I still want to do an inequality statement. So my inequality statement, again, I always look at my target numbers. -3 is less than 6, so I'm going to start with this one. X is less than -3. I must include the word or. X is greater than or equal to 6. So this is the inequality piece. And now I need to graph and put it in interval notation. And you notice from my inequality piece that the arrows are definitely going to go apart because this arrow goes to the left and this arrow goes to the right. So when I graph, open circle on -3, shade to the left, close circle on -6, shade to the right. So where does this graph begin? At negative infinity to -3, open circle, or, make sure to write or, block at 6 to infinity with a parenthesis. So 3 different pieces that I'm looking for there. Let's jump down to number 5, okay? So first step is to distribute, so I get -6x minus 3 is less than -15. Add 3 to both sides. -6x is less than -12. Don't forget, when I divide by a negative, a light should go off in your head going ding, 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 ding. I must flip my sign when I multiply or divide both sides by a negative. So here I have x is greater than 2. When I solve the second piece, I subtract 1, and I have -x is less than or equal to 4. I'm going to flip out on this one. So I'm going to flip my variable, I'm going to flip my sign, and I'm going to flip my constant term. You'll notice here that when I write it in my inequality piece, I'm going to start with this one because negative 4 is less than 2. So my target number, x is less than or equal to negative 4, or x is greater than 2. So I had to rearrange those because negative 4 is going to come before 2. So that's the piece I boxed for my inequality statement. When I graph, I'm going to bubble in negative 4, shade to the left, or open circle on 2, shade to the right. So when I do interval notation, I start at negative infinity all the way to negative 4, blocked off on negative 4, or parenthesis around 2 to infinity with a parenthesis. So hopefully that makes sense. It's just one more step. So that's the first type that we look at is an or statement. The second type we're going to look at is an and statement. So an and statement is just going to be one single line. So an and statement is going to look a little bit different. But and inequalities have a tendency to graph together. So for an example on this one, I have x is greater than or equal to negative 6 and x is less than or equal to 1. Notice those lines, because my target number is to the left, negative 6 is less than 1, my arrows are going together. So that means they're going to match up. But this is not the correct way to write the inequality statement. So this inequality statement is going to look a little different. The graph, you can still graph it, close circle on negative 6, shade to the right, close circle on 1, and shade to the left. So notice those lines come together and I have one solid line. Interval notation, it's just where it starts on the left and where it ends on the left. So it starts at negative 6, blocked off, and it stops at 1, blocked off. So because the solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form. So the inequality statement is going to be more condensed. And because there's one line, there's one variable. So here's how this statement was written, but that's not how we write it. What we do is, for me, it's easier to look at the graph. So I know x is going to fall all in here, and it's going to fall between negative 6 and 1. So I'm going to write it as negative 6, x, and 1. Now, what is it doing? Well, it's telling me x is less than or equal to 1, and x is greater than or equal to negative 6. So my arrows will always be facing in this direction, where it goes to the left, if you write it correctly with your target number less than this one. Okay, so they're always going to go between each other. So arrows are always going to face the same direction on an and statement. And we'll take a look at how that looks when we solve them. So and statements are frequently written when you have to solve them like this. So we can do it at one time. I want x to be in the middle, so I'm going to subtract 4 everywhere. Remember, it's still talking, when we have algebra, it's still equality, so we got to do whatever we do to the left and to the right. So 2 minus 4 is negative 2, less than or equal to x, because that cancels out, and less than 5. So my inequality statement is already written for me. Negative 2 is less than 5 and x is between. Arrows are pointing in the same direction. So when I graph it, I'm going to bubble in negative 2. I'm going to open circle 5, and then that line falls between them. So you'll notice what it says. It says x is less than 5 and x is greater than negative 2. And so interval notation, where does it start? It starts at negative 2 and it ends at 5 with a parenthesis. Let's take a look at number 8. So number 8, I'm going to add 4 to both sides. So I get negative 12 is less than or equal to 3x, because that cancels out, which is less than or equal to 6. I'm going to divide everything by 3. It's positive, so I don't need to worry about my signs. So I get negative 4 is less than or equal to x, which is less than or equal to 2. Notice negative 4 is in the correct location because it's less than 2. X is in the middle, and my arrows are on the same direction. So that's correctly written. So I'm going to circle in negative 4. I'm going to close in negative 2, and x is less than 2. And if I read it this way, x is greater than -4. So it's one line. My interval notation, it starts at -4, blocked in, and it stops at 2, and it's blocked in. So I've written it 3 different ways. Last one we're going to take a look at is number 10. So I still need to distribute. So I have -2 is less than 2x minus 12, which is less than or equal to 4. I'm going to add 12 on all sides, and I get 10 is less than 2x, which is less than or equal to 16. I divide both sides by 2, and I get 5 is less than x, which is less than or equal to 8. 5 is less than 8, so that's written in the correct order, and x is in the middle, and arrows are in the same direction. So I know that I'm on the right track. So it's open circle on 5, closed circle on 8, and they form one line and they go together. So my interval notation is going to be 5 parenthesis, and then it's going to end at 8 with blocked off, like that. So those are your compound inequality statements. Come see me if you're having trouble.